All right, guys, continuing through this linear algebra test. Hopefully you're studying pretty hard for your exams. We're moving to the above section. And as you can see, the three above questions seem to be quite similar, and that's because they basically work on a method that's called the crossover method. We've been over it a lot of times, but today we're going to go over it once again. Why not? How does the crossover work? Well, I'm just going to move this piece of paper and I'm going to write down the question that we had. So x plus 4 over 3 is equal to x plus 6 over 4. Now, the crossover method works. Well, hang on, we'll bring this in a little bit so you can actually see it. Because basically what we would do if we were going to solve this first, we would need to get rid of this 4. If you remember our division trap, we can see that the 6 is covered by the 4. So we would have to times by 4. I'm just going to cover up this side in particular, because if we did that, on the other side of the equal sign, we would also need to times by 4 on this side. And what that would do would be to get rid of this. Okay, now what I'm going to do is we're going to ignore that times 4. We're going to go over here. And if I was going to do the same thing, if I was going to get rid of this divide by 3, and because I have to, because I can't access that 4 at the moment, because it's being divided by all of the 3, I would simply times 3 on this side. And that means that I would cancel that out. But we remember, of course, that we would need to times by 3 on this side of our equation. Now, if we bring it back out, we can see that we've got 4 lots of this, but it's not 4 lots of just x, it's 4 lots of the whole thing. And if you remember from the last video, to write that in maths, we use a bracket to say, well, we're timesing all of this by 4, and that's why the bracket is there. If we look on the other side, hopefully you can write for me what's going to be there, we're timesing this by 3. So this, of course, would be 3 times x plus 6. Now, why do we call it the crossover method? Because, now, it's not a method, I suppose. It's just a way in which to think about this, because this is what's actually going on mathematically. But we have taken this 3 up the front and gone 3 times x plus 6, and we have taken this 4 over here, and we've gone 4 times x plus 4, is equal to, and it forms a little cross, so we call it the crossover method. It is basically a thing that we already know, like we learnt this last video, I suppose, when we looked at the division trap, but we're just doing 2 steps at once. So the crossover method is, I suppose, a way to represent something that's going on mathematically that we already know how to solve. It's not well, I don't know what I'm trying to say here, but hopefully you do. So we'll go back to this and we'll do our crossover method. We'll get 3 lots of x plus 6. And of course over here we'll get 4 lots of x plus 4. So I might need a little bit more room here. If we look at this, I go 3 times x is 3x and 3 times 6 is 18. I go 4 times x is 4x. And 4 times 4 is 16. Now, I'm just going to check that I did that right, because sometimes I forget to go 4 times 4, which is 16, good, and 3 times 6, which is 18. Excellent. Pretty sure? Yes, I'm happy with all of that. And now I'm back to a question where I've got x's on both sides. Well, that's okay, because I learnt when we've got x's on both sides, I just take one away from the other, and that will leave me with 18 on this side. And on this side, 4x's take away 3 is 1x plus a 16. Well, now I know what to do. I just need to get rid of this positive 16 by taking 16. So I'm going to take 16. And x, of course, is going to be equal to 2. So I've solved that particular question. Now I can check. Okay, well, x plus 2 plus 4 divided by 3 is equal to 2 plus 6 divided by 4. So, 2 plus 4 is 6, 6 divided by 3 is 2, and 2 plus 6 is 8, 8 divided by 4, of course, is 2, 2 equals 2, brilliant, okay? Of course it does. So, I am sitting pretty. So, there is very little difference between the next question and that first one, apart from the fact that this one gets a little bit more complex. It's got some coefficients or numbers, some negatives, and I'm probably not going to go over that one, but I am going to look at this one. And I'm going to look at this one because kids kind of go, wow, well, I don't really know what to do. Number one, I should probably move that up there. because that's where it sits, and that's going to confuse kids. But the problem is kids go, well, how can we do the crossover method? Because there's nothing over here to cross over. Well, I would disagree. Remember, if you ever get a whole number and a fraction, you can represent the other whole number as a fraction. You can just put it over 1. The other thing kids get confused about is that, hang on, there's already a 3 here, and there's a 5 there. Well, there's 2 ways in which you can do this. I simply would go, okay, I'm going to cross it over. In other words, I'm going to times this by 5, and I'm going to times that by 1. And I would get 5 lots of this. Now, I'm actually just going to go 5 times 3 is 15. And then x plus 1 is equal to 1 lot of 2, which is 2, x plus 2. So I've taken this 5 and I've times it by that 3. Now, let's see if I can do that, because some people say, you can't do that. Well, 15x plus 15 is what I'd end up with when I expanded that particular bracket. So let's go back up, take a step back, and we'll go, okay, can we see that? Yeah. We'll go 3x plus 1, and let's expand this first. We get 3x plus 3 is equal to, well, 2x plus 4. We've expanded this one up here, over 5, and this, of course, we're going to have to put over 1. So then we would cross multiply, and we would get 5 lots of 3x plus 3, and we would get 1 lot of 2x plus 4. Well, I mean, that's just going to be 2x plus 4, but 5 lots of 3x is 15x, and 5 lots of 3 is 15. So, can I do that? Yes, well, of course, mathematically, I've just proved that I can. So that is, of course, the same answer as that. So, if we have a look, I'm going to go over here, 2x plus 4, and I'm going to go, well, okay, I've got 2x's, so I'll take them away from these 15x's, 2x's, that's 13x. Plus 15 is equal to 4. Then I'm going to have to take away 15. And from 4, I'm going to take away this 15. And that's going to be, what? Minus 11? 13x. And, of course, divide through by 13 and divide through by 13. So I'm going to get x is equal to negative 11 over 13. Now, can it be a negative and can it be a fraction? Well, of course it can. Putting it back in there, I'm not going to do it right now, but you could, and hopefully these 2 things, well, they probably and most likely will be exactly the same on either side, like we had our 2 or a 2. So that's we'll just have a look at the other half of it. So if we have a look at the other side of your test, you can see that this question is exactly the same. Oh, you can't even see it. There we go. That's going to make it a little bit better. So this question here is exactly the same as the one we just did. So if we get a little bit stuck, well, we can just put that over 1 and then cross multiply again from that particular place. All right, so that was cross multiplying, probably a fairly important part of this unit and the above. And remember, cross multiplication is because of the fact that we are timesing to get rid of this 6, and we have to before we can access the rest of this particular question. This one here, just be careful of your minus 4 times your minus x. That'll give you positive 4x. A minus and a minus gives you a plus. Thanks, kiddies. See you later.